Hi, everyone. What we're going to be studying today are basic trig identities. So, an identity is just a statement that would be true for all values. So, I have an example here where x squared minus y squared, that's the difference of squares, can be factored to look like this. Okay, so a trig identity is a statement of equality between two trig expressions that's true for all values, all variables. Okay, and we're going to get into that in a little bit. And of course, a counterexample would be something that specifically shows that a trig identity or something that someone might be saying is a trig identity is not actually a trig identity. We don't really do too much with this, but I wanted to give you an example. So, my example is that I want you to prove that the sine of x times the tangent of x equals the cosine of x is not a trig identity. And I'm asking you to suppose that x is pi over 6. So essentially, we'll be showing that the sine, oops, let me get that other pen, it's better, that the sine of pi over 6 times the tangent of pi over 6 actually does not equal the cosine of pi over 6. Okay, so we're going to start off by stating like that it does equal it. So of course, the sine of pi over 6, maybe you're thinking of the unit circle. Okay, we're looking at this triangle right here. The sine of pi over 6 is 1/2. The tangent of pi over 6, remember more threes, is root 3 over 3. And the cosine of pi over 6 is root 3 over 2. Well, if we multiply this together, we get root 3 over 6 equals root 3 over 2. And of course, that is not true. So that means that this trig identity was not actually an identity. Okay, to be honest, we're not going to be working with that so much. What we're going to be working with will be values that actually are trig identities. So let's take a look at the bottom. And we already know 6 trig identities because you, of course, know your reciprocal identities. So we know that the sine of theta is equal to 1 over the cosecant of theta. Well, that must mean that the cosecant of theta equals 1 over the sine of theta. So that the cosine of theta is equal to 1 over the secant of theta. That's an identity. That's true for all values of theta. So it's also true that the secant of theta is equal to 1 over the cosine of theta. And this should be old news. We already know these. Maybe you have to rememorize them, but you should know these. How about the tangent of theta? We know that the tangent of theta is equal to 1 over the cotangent of theta, right? We'll say tangent and cotangent are reciprocals of each other. Therefore, the cotangent of theta is equal to 1 over the tangent of theta. Now, you're going to hear me say this a lot. You are going to need to memorize these. Like, memorize them just like you memorize the unit circle because we're going to be using them for a long time. Okay, let's take a look at the next page and look what we have. We have the unit circle, and we're going to be thinking about this unit circle. And of course, we'll just make an angle here. No specific angle amount, but of course, inside, this is our theta. We know that this value right here is our x value. And we know, of course, this value right here is our y value. And of course, it's a unit circle, so that's 1. So we know from just, SOHCAHTOA that the sine of theta equals opposite, which is 1, over the hypotenuse, which just really means that the sine of theta equals y. And the cosine of theta equals the adjacent, which is x, over 1. So what we really know is that the cosine of theta equals x. Therefore, let's take a look at tangent of theta. Tangent of theta equals opposite over adjacent. But what do we know? We know that y is the sine of theta. And we know that x is the cosine of theta. So really, the tangent of theta equals the sine of theta over the cosine of theta. So this is what we call a quotient identity. We'll have two of them. So the first one is what we see right here, that the tangent of theta is equal to sine of theta divided by cosine of theta. It's going to be super important. And now on the previous page, we talked about reciprocals. Well, the reciprocal of tangent is cotangent. So the cotangent of theta is equal to this flipped over. So cosine of theta over sine of theta. Okay, so those are called the quotient identities, and they're going to be very helpful to us as well. I know you're probably thinking, how is this going to help me? But it's going to once we get into these problems. Okay, so let's take a look again at the same unit circle we just talked about, and we'll just sketch this out again. We know that this is x. We know that this is y. We know that this is 1. Okay, and so if we were to think about Pythagorean theorem, okay, we would know that y squared plus x squared equals 1 squared, which is just 1. Well, how about we think about sine and cosine now? So we said earlier that y, when we're in a unit circle, y is the sine of theta. So really, we know that the sine squared of theta, and watch how we write it, sine squared of theta plus the cosine squared of theta, I substituted that in for x, equals 1. So this really means sine of theta times sine of theta. We insert the 2 in here, okay, for the squaring. So that is our first Pythagorean identity. That is right here for sure. This is the most important identity. But we're actually going to have a couple of versions of this. So I'm going to scroll up here. So that's the first one we're going to write here, is that the sine squared of theta plus cosine squared of theta equals 1. Now, if we take this and we move some things around, it might look a little different. So, for example, if I subtracted the cosine squared to the other side, we would now say that the sine squared of theta equals 1 minus the cosine squared of theta. It's just a different version of the original equation. And in the same thinking, if I looked at my original equation and I subtracted sine squared of theta to the other side, we would see that the cosine squared of theta equals 1 minus the sine squared of theta. Okay, so absolutely, you're going to need to memorize this, but also these are super important because they're going to come up over and over again. So the more you can memorize these, the better. Okay, so what else can we do here? Well, what if we took this equation and we divided everything by sine squared of theta? Let's look at what would happen. So we would have sine squared of theta divided by sine squared of theta plus cosine squared of theta divided by sine squared of theta equals 1 over the sine squared of theta. This is actually going to give us another identity. Because look what we have here. Sine squared of theta over itself is 1. The same way that up on the top of this page we had cosine over sine equals cotangent, well, cosine squared of theta over sine squared of theta equals cotangent squared of theta. So we're using that quotient property from the top half of this page, but now we just have squared values. And we have a reciprocal here. 1 over the sine of theta is cosecant of theta. So 1 over the sine squared of theta is cosecant squared of theta. And that actually becomes our second trig identity. 1 plus the cotangent squared of theta equals cosecant squared of theta. Now, it's super important that you memorize this, but equally important, if you forget the identity, remember that the way we got this was we took the first trig identity and we divided everything by sine squared of theta. Now, there would be three versions of this now, wouldn't there? What if I subtracted cotangent squared of theta to the other side? We would have 1 equals cosecant squared of theta minus cotangent squared of theta. Okay, so that's going to be important. And if we kept cotangent squared of theta and subtracted 1, we would have this identity. Cotangent squared of theta equals cosecant squared of theta minus 1. Make sense? Hopefully. All right, so look, we have room for one more, which will actually become 3. And I'm going to go back up to here. You probably have more room than I do. I'm going to go back to this. And I'm going to take our original trig identity, our Pythagorean identity, and now instead of dividing by sine squared of theta, we're going to divide by cosine squared of theta. So let's see what happens. We're dividing by cosine squared of theta to the entire equation. Whoops, cosine squared of theta. And let's see what we get. Well, sine squared of theta over cosine squared of theta, using the quotient property at the top half of this page, would give us tangent squared of theta. Now, cosine squared of theta over cosine squared of theta is 1. That was easy. And 1 over cosine squared of theta, we're using our reciprocal identities. We know 1 over cosine is equal to secant. So 1 over cosine squared is equal to secant squared of theta. And of course, there are 3 versions of this, aren't there? So we'll subtract 1 to the other side. We're left with tangent squared of theta equals secant squared of theta minus 1. And if we keep the 1 here and we move tangent squared of theta over, we will get that 1 equals secant squared of theta minus tangent squared of theta. Again, memorize, memorize, memorize. You're going to be so much better off if you have all of these memorized. Okay, moving right along. So we have added a couple more in here, and these are the trig identities of complementary angles. And this is something that has appeared on SAT, so we kind of feel like it's important. So let's take a look at this. And this you might actually, I'm going to give you specific examples, and you're going to think, oh yeah, I kind of noticed that anyway. So first of all, the sine of 90 minus an angle is equal to the cosine of that angle. These are called complementary identities. The cosine of 90 minus an angle is equal to the sine of that angle. So let's see if we can come up with something here. Let's think about our unit circle. Give ourselves a circle. It's not great. Okay. And let's just think of an angle that we know. We certainly know a 30-degree angle, don't we? So let's look at what we have here. We'll give ourselves a 30-degree angle. And of course, we know that the sine is 1/2. We know the cosine, of course, is root 3 over 2. And we know this is 1. So let's take a look at this. The cosine of 30, I'm going to write it backwards. Okay, so the cosine of 30 equals the sine of 90 minus 30. What is the cosine of 30? Well, we have it right here. It's root 3 over 2. What is the sine of 60? Well, if you think about that angle, wouldn't that look like this? And the sine of 60 is root 3 over 2. So that's a very specific example for this. Okay, and in the same fashion, this one would work. So the cosine of 90 minus an angle is equal to the sine of that angle. Okay, and I'm sure you can come up with examples on your own for that. Very similar. Next, we have supplementary identities. So looking at this one, the sine of 180 minus an angle is equal to the sine of that angle. And similarly, the cosine of 180 minus an angle is equal to the negative or the opposite of the cosine of that angle. So let's think about our unit circle again. Can never stop thinking about our unit circle. And we'll pick an angle for ourselves. Let's see. Let's go with 135. So this is 135. Let me get that other pen. It's better. Okay, and as we label this, we know this is a 45, 45, 90. So this is negative root 2 over 2. This is positive root 2 over 2. And of course, it's a unit circle, so that's 1. So let's do the first one. The sine of 180 minus 135 is equal to the sine of 135. All right, let's think about this. What is the sine of 135? Well, it's root 2 over 2. 180 minus 135 is 45. And we know the sine of 45 is root 2 over 2, right? Because that would be a triangle that would be right over here with root 2 over 2. Okay, so that's, again, one specific example that shows that property. And let's go ahead and use the same triangles for cosine. So the cosine of 180 minus 135. So now I'm going to do this one right here. So the cosine of 180 minus 135, so in other words, the cosine of 45, is equal to the opposite of the cosine of 135. All right, let's look at this. The cosine of 45 is root 2 over 2. And that's equal to the opposite of the cosine of 135, which is negative root 2 over 2. Well, there you go. Plus, plus, it worked. Okay, so here's what you need to do. You need to memorize, 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 because we are going to be using these properties over and over and over again. Have a great day, everybody.